So today we are going to learn about something called the triangle inequality. The triangle inequality. In order for three segments to form a triangle, a special relationship must exist among their lengths. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. The sum of any two sides of a triangle must be greater than the third side. We can check to see if a triangle can exist by seeing if the sum of the two smallest sides is greater than the third side. We don't need to check all of them. I don't need to add all of the pairs of sides together because I know that if I add the biggest side plus one of the sides that's not the biggest side, it's going to be bigger than my other side that's not the biggest side. All right, so let's look at this. Example number 1, part A. On example number 1, we're going to check all of the pairs and see what happens until we find one that breaks it. And if we don't find one that breaks it, then we'll say, yes, it makes a triangle. But most of the time, we're just going to pick out the two biggest sides and check those. Or sorry, two smallest sides to check to see if it's bigger than the biggest side. I misspoke, sorry. All right, so is it possible to form a triangle with the given side lengths? If not, explain why not. So here's my side lengths, 9 centimeters, 12 centimeters, and 18 centimeters. So we're going to add each pair of sides together. Let's start with 9 and 12. When you add 9 plus 12, you get what? What is 9 plus 12? 21. 9 plus 12 is 21. Is that greater than, less than, or equal to 18? Greater than. So I'm going to put my inequality here on the line that this is a greater than. Then my next pair of sides, I have 12 and 18. Well, 12 and 18 are obviously going to add up to be bigger than, smaller than, or same size as 9. Bigger than. I know those are going to add up to be bigger because each one by itself is bigger. If I add these together, though, what do I get? 30. Same thing over here with the 9 and the 18. 18 is already bigger than 12. So if I add something onto the 18, if I add 9 to the 18, will that be greater than, less than, or same size as 12? Greater than. And in fact, if I do add these two together, we know that it comes out to be what? 27. Because the sum of each pair of side lengths is greater than the third side length, sides with lengths 9 centimeters, 12 centimeters, and 18 centimeters can form a triangle. Part B, my sides now are 3, 5, and 8. So we're going to start checking our sides. I'm going to take 3 and 5 first. When I add 3 and 5, I get what? 8. So what should I put on this line here? Equal. Do I want these to be equal? Was that what we were looking for with our triangle inequality theorem? No, I want it to be greater than. This came out to be an equal to. I don't even need to check the rest of these inequalities. I don't even need to check the rest of these sums. Because the sum of each pair of side lengths is not greater than the third side length. Sides with lengths 3 inches, 5 inches, and 8 inches cannot form a triangle. Before we go on and look at example number 2, I want to explain why we're looking at this inequality. So I want to kind of show you with my pencils here. I've got 2 little stubby pencils and then 1 white colored pencil. If my 2 smaller sides, when I add them together, are not bigger than the third side, then what ends up happening, if I put these sides together to make corners and I try to make a triangle, as I bring these 2 smaller sides closer and closer together to make that top point, do they ever meet? No. And in fact, even if I lay it flat against that third side, see the gap in the middle? Because these 2 were not bigger than the third side, they're never going to be able to make a point at the top. However, if they are bigger than the third side, and I start to bring them together, then it does make a point at the top. If the 2 smaller pieces add up to be bigger than the third side, then I can get a triangle. Otherwise, I cannot. Does that make a little bit more sense why we're checking this? All right, let's look at example number 2 then. Is it possible to form a triangle with the given side lengths? If not, explain why not. So I only really need to check, like I mentioned before, the 2 smallest sides to make sure they add up to be bigger than my biggest side. On example A, what are the 2 smallest sides? 2 and 5. So we're going to take 2 and 5. We're going to add them together. What do we get when we add 2 and 5 together? 7. So I get 7 millimeters. When I compare that to my third side, which was my biggest side, is the sum greater than, less than, or the same as my biggest side? Greater than. So can this form a triangle? Yes. Yes, we can make a triangle. We are going to explain. We're going to say the sum of the 2 smallest sides is greater than the third side. What about with B? What are my 2 smallest sides? 3 and 4. So I'm going to take 3 and 4. I'm going to add those together. And what do I get when I do that? I get 7. When I compare 7, the sum of the 2 smallest sides, to my biggest side, which is 8 yards, is it greater than, less than, or the same as? Less than. Well, if I add the 2 smaller sides together, and it comes up to be smaller than my third side, that's this situation right here. They're not going to meet to make that point at the top. So can we make a triangle out of these 3 segments? No. So I would say no. No triangle. My reason for that would be the sum of the 2 smallest sides is not greater than the third side. If it's not greater, then we cannot make a triangle. If it's not greater, then we cannot make a triangle. All right, let's go ahead and flip the page. On your homework, that by the way is due on Monday, but you should be able to get it done before you leave for the weekend because we're almost done with this lesson. On the homework, you have questions that are kind of like example number 3. It says, is it possible to form a triangle with the given side lengths? I want to see your work. Show me that you added the 2 smallest sides together and compared it to the third side before you just tell me yes or no. So you do need to give a yes or a no, but I also need to see the work that justifies that answer. So looking here at example 3, part A, here's my triangle. What are the 3 side lengths that we are going to be used to compare? What are the 3 side lengths? 6.2, 8.7, and 9.3. They gave us this extra piece in the middle, but that's not a side of the triangle, so I'm totally going to ignore that. Which of those 2 sides are the smaller 2 sides? 6.2 and 8.7. So we're going to add those 2 together. 6.2 centimeters plus 8.7 centimeters. And I want to know, how does that compare to 9.3 centimeters? What do I get when I add these 2 together? 14.9 centimeters compared to 9.3 centimeters. Alligator eats which one? Thinking about my inequalities. Alligator mouth eats the bigger thing. Which one is the alligator going to eat? 14.9. Can this make a triangle? Yes. I would say yes, triangle. Can form a triangle. So this is like what I want to see for the work on the first 5 problems on your homework. I want to see where you added the 2 smaller sides together and you compared it to the third side, and then you gave me a yes or no, it can make a triangle or it can't make a triangle. I'm going to give you guys about a minute to do part B. Take about a minute to do part B on your own. I'm sorry. My apologies. You're welcome. Can this make a triangle? No. Give me the justification. What do I need to compare? What is the pieces I'm adding, and I'm comparing it to what? Yes, we're going to compare 20, or we're going to add 29 and 19. So 29 plus 19. And we are going to compare that to the biggest side, 48. What do we get when we add 29 and 19 together? We get 48. What symbol should go between them? Equals. Do I want them to be equal? No. So I would say no. The sides cannot form a triangle. All right, again, this is the kind of thing that I want to see on your homework. And just to be clear, so that we all understand why, I don't want them to be equal, why it specifically has to be greater than. If it is equal, then my two smaller sides, when I put them together, would just lay flat against my third side. It wouldn't actually make a triangle. It has to be bigger to make that pop up and make that triangle, to make that top point. All right, we've got one more concept to cover today. When the lengths of two sides of a triangle are known, so if I know two sides of a triangle, the third side can be any length in a range of values. The third side can be any length in a range of values. So instead of me telling you all three sides and saying, can this make a triangle? I'm only going to tell you two sides, and I want to know what's the biggest the third side could be and still make a triangle. What's the smallest the third side could be and still make a triangle. So we are going to find the upper and lower bounds on the third side of the triangle. Here in example 4, I have two sides of a triangle that are 39 inches and 15 inches. To find the upper bound, we are going to add. So I'm going to take my two sides, 39 and 15, and add them together. What is 39 plus 15? 54. So that's my upper bound. To find the lower bound, okay, so if I add for the upper bound, what's your best guess for what I need to do for the lower bound? Minus, yes, we will subtract. So I would do 39 inches minus 15 inches. Always make sure when you're going to find the lower boundary that you do the bigger number minus the smaller number, because we can't have a side of a triangle that has a negative measurement. That doesn't make any sense. What is 39 minus 15? 24. All right, so the way I write my final answer to show my upper and lower boundaries, the third side of the triangle has to be bigger than 24 inches. So I have the inequality, alligator, each the third side because it has to be bigger than 24. But it also has to be smaller than my upper boundary, which is 54 inches. So 24 inches is smaller than the third side. 54 inches is bigger than the third side. When I write my compound inequality like this, it says the third side is in the middle or in between 24 and 54. Let's try part 5, or example 5 over here. What are the two known sides that we have? 14 and 22. So to find my upper bound, I'm going to add. So I'm going to add 14 and 22 together, and that would give me what? 36. And then my lower bound, Again, for the lower bound, we subtract. So do I do 14 minus 22? Why not? Because I'll get a negative. We can't have negative lengths on triangles, so we have to do 22 minus 14, which comes out to be, what's that come out to? 8. All right, so then I'm going to write my answer. I don't just want to say third side on this one. Over here, I didn't know anything about the triangle except the lengths of the sides. Over here, I actually have a triangle name. It's called triangle ABC. So if I know side AB and I know side BC, what would the name of the third side be? AC. So AC goes in the middle. It is bigger than 8. It is smaller than 36. When you write your compound inequality, just like on a number line, the smaller number goes on the left and the bigger number goes on the right. And remember, alligator always eats the bigger thing, so we're going to have less thans because the biggest thing will always be over on the right. Awesome, thank you. All right, we've got 2 examples left to go and then we're done. Example number 6. A delivery company uses drones to make speedy deliveries around the city. A drone leaves the home office and flies 8 miles east to its first delivery, and then 4 more miles southwest to the second delivery. What are the upper and lower bounds for how far the drone will fly to return to the home office? So let's do the upper bound first. What would the upper bound be? 8 plus 4. And what is 8 plus 4? 12. So my upper bound is 12 miles. What would the lower bound be? 8 minus 4. What do I get when I do 8 minus 4? 4. So we do 8 miles minus 4 miles equals 4 miles. And so my answer, we have the return flight. Return flight has to be bigger than what? 4 miles, yep. But smaller than 12 miles. Return flight has to be bigger than 4, but smaller than 12. How are we feeling about this so far? Is this okay for a Friday right before a weekend? All right. We're going to complete this short proof down at the bottom. Notice there's only one statement we need to fill in and one reason that we need to fill in. We have this figure over here, and it tells me that it is 2 triangles. I don't have to guess whether or not it forms a triangle. We have triangle HAB and triangle HCB. They share side HB. So this side right here is in common between the 2 of them. And HC has a length that is the same size as HB. In fact, that's my given information right here. So I'm going to mark that on the picture. HC right here is congruent to HB right here. We want to prove that if I add sides HA and AB together, it's bigger than HC. Well, let's go find all 3 of those sides that it's talking about here. HA is this side right here. And AB is this side down here. But HC is over here. Is that part of this little triangle on the bottom? No. In fact, that little triangle I'm going to like shade in purple so it's easier to see. HA and AB are both sides of the purple triangle, but HC is not. What's the third side of the purple triangle? We have HA and AB. What's the third side of the purple triangle? HB. Well, it tells me here that my reason is triangle inequality theorem. The triangle inequality theorem is what we learned today, where the two sides, any two sides of a triangle, have to add up to be bigger than the third side. So I can't jump right here because HC is not a side of the purple triangle. But I can look at the three sides of the purple triangle, HA and AB. Those should add up to be bigger than HB, than this side. So HA plus AB is greater than HB because it is the third side of that triangle. Any two sides of a triangle, like these two, will always add up to be bigger than the third side of the triangle. That's what my triangle inequality theorem tells me. There's only one more step in this proof, and there's a lot that stays the same between statement 2 and statement 3. In fact, what's the only thing that changed between these two statements? The third side. HA stayed the same, AB stayed the same, but this changed. Why would I be allowed to take HB out of this inequality but replace it with HC? Because they are congruent. So what reason could I use? Substitution property. Yes, the reason I can use substitution is because they are congruent. That lets me take something out and replace it with something of equal value. This is substitution property. Nicely done. That is everything we are covering for today. We are done with your notes. As I mentioned before, your homework is due on Monday. It is a front side only. There's no problems on the back. There are 5 problems that are like the first set of examples that we did, where I want to know, can this make a triangle? And then there are 2 problems where I want you to find the upper and lower bounds for the third side. You guys have the remainder of class time to work on that. There should be no reason why you have to take this homework home. Unfortunately, if you get it done in class, I can't take it from you today because I don't have anywhere to keep it. So when you get done with the homework, just put it in your folder and save it until Monday. While you guys are working on that, I am going to go ahead and pass back the tests from yesterday so that you can see how you did on those and you have the opportunity to ask any questions you might have about those. If you don't like your score on the test, you have until December 10th. You have until December 10th to complete a retake if you're not happy with your score. And if you don't know what the requirements are to do a retake, please make sure to come and talk to me. I will go over all of those requirements with you.